There's no streaming, at this point, but everything is recorded on my own laptop. All right, so what we are going to do today is to go over the exam in spring 2022. You all have a copy to that already. I sent you guys all a link through the announcements. I hope you guys had a chance to take a look at it because that's what we're going to be working on. Um, so I'm going to describe not only the answers to the questions, but also the approach. Now, how are you going to use this particular session is entirely up to you. But I would not make the assumption, okay? I would not make any assumption that your exam one is going to be like the exam one that you see today from spring 22. So just kind of do not make that assumption because I usually try to make variations of a test in different semesters. So it doesn't hurt to go back to the announcements and just kind of quickly go over what I have sent you already. So exam one from spring 22 was given to you on September 16th, so that's last week, sometime. And so is the exam policy and preparation guide. I'm not sure how many of you got the time to actually open this and read it. The exam policy is, I'm going to assume everybody has a chance to read the exam policy by the time we have exam one, which is 1 week from Thursday. Okay, so you guys are going to get your exam one on Thursday. So if you have not done so, please read the exam policy. I can go over that possibly on Thursday if people want me to go over that. The next document is the exam preparation guide, which is entirely optional. Okay, so that means if you do not want to read about this one, the exam preparation guide, you don't have to. Okay, if you already have a very successful way that has been proven over time and you know how to do all this stuff, hey, there's no need to actually read mine. Okay, on the other hand, you can always just kind of read it and go like, nah, okay, I got a better way to do this, I got a better way to do this. This one I kind of like. Okay, so you can still integrate, things, from my preparation guide, which obviously is based on my own personal experience, taking classes in college. Okay, so I'm not you. I cannot tell you how you can do it, but I can tell you how I did it, myself. All right, so with that said, we're going to take a quick look at the first question of exam one. I think we might have taken a look already in the past, but I'm going to kind of go over that in more details today. All right, so every exam is going to start with some instructions. Just be very careful and read the instructions, okay? Because the instructions may not be the same as the one from the previous semester. One thing that is changed, kind of dramatically between this class and spring 22 is this class is in person. So you are taking the test in person on paper, no electronics. So if you have been taking notes with your iPad, you just need to print out or kind of create a paper copy of whatever note you have taken. You can print out anything. Okay, so this is the gist of it. Anything that is either handwritten or printed prior to the test, you can bring with you. Yep. So if you go to the library and check out, wow, there are 16 books that I think will be helpful for this class. Get a flat truck, haul the 16 books in. We got enough space in this classroom to space out everything. If that is what you think you need, okay, my personal recommendation is to consolidate all the material into a condensed version of notes intended for exam one. So you're creating, pages of notes just for the exam. Why would you want to do that? One, the process of doing this is study because you're basically going through, with a fine comb, the big helmet, scene, just appeared in my head with a big comb in the desert. You guys are way too young to know Spaceballs. Anyway, um, yes, so with a fine tooth comb, you want to go through all the material and extract what you think is useful. Okay, so you might have to go through like a few iterations because I would put all the definitions in one place, clearly, designate that place. all the techniques, you go to yet another place, and so on. So by creating this condensed version of everything that you have learned up to this point, you are studying, okay? It just doesn't feel like studying because your objective is to create the condensed version of the notes. The other reason why this is going to be helpful is the condensed notes was created like a week before the exam. So the chances of you remembering where I put all the definitions, where I explain, the multi-digit addition thing, where I explain, what is R, what is C, what is B as functions, you probably remember where it is a lot better than remembering where they are in my notes, okay? Because they're kind of buried in my notes. So just a recommendation, consider making your condensed version of everything, including, just summaries of the modules. Now, can you print the modules and bring that with you? Absolutely. Okay. If you want, you can just copy and paste the modules into Google Doc, do all the editing, move things around, highlight and whatnot, and print it out and bring it with you. Okay. That's perfectly okay as well. Well, here comes a veteran, someone who knows, well, when we can bring anything we can, bring to help, it cannot be easy. The idea is I'm not okay. It depends on how you define, easy versus hard. I'm testing whether you guys can apply what you have learned in this class. I'm not testing whether you have the knowledge or not, because the knowledge is easy. Okay, these days we got Google, we got all the search engines. I mean, that's the easy part. But how you apply what you have learned, that is a little bit harder. And that is also how I can assess whether you understand a concept or not. Otherwise, how do I know whether you understand something or not? I can test whether you know something, but I cannot test whether you understand something unless I give you a problem to solve utilizing what you have learned. Does that make sense? Does everybody understand the difference between knowing versus understanding? Maybe? Okay, all right. Okay, so moving on. Okay, so this is question one of six, which is the hardest version of this kind of question. And then question two is a little bit easier because it gives you more things that are known. And then question number three should be the easiest because it gives you the most zeros and ones, at least in this particular version of the test. And then question number four is based on base, let's see, it's not base, it's base 6 addition. It's base 6, multi-digit addition. So it's basically testing whether you really understood the concept of multi-digit addition using, in this case, because it's addition, so it is about the R function to do the single digit sum and the C function that will give you the carry to the next digit. So we'll work on all of this stuff today. I'm just giving you a preview of what we're going through. And as usual, whatever is on the screen, my voice is it's all getting recorded. So you want to kind of take notes, based on your own understanding of the material, and also the timestamp. If you think, there's a certain section that you might need to go back to review. All right. So with all that said, we are going to get started here. So we're going to start with this particular problem to try to resolve, all the question marks given, the zeros and ones. Okay, this one should be the easiest one. So we'll start with an easy one to kind of ramp up the difficulty level. So I will do the usual thing, which is to copy and paste this, into, let's see, is it visible to you? Yep. Okay. So I'm going to copy and paste it into Zernal. And, oh, okay. Into Zernal right here. There we go. Okay. It takes a little bit. There's a little bit of lag between what I see and what you see. And then I'll work on it. All right. So the first thing is, how do we get started with something like this? I mean, what is the general approach of answering any question of any test in any one of your classes? Where do you start? The objective, first of all, you have to understand what is the objective. In this case, it's fairly obvious. Resolve all the question marks. So we want to know what each question mark is supposed to be. Is it supposed to be a 0 or is it supposed to be a 1? That is your objective. Next, how do we get this started? Yep. You look at what you're given in the question. So all of these zeros and ones that are given to you. So let me just point out what I mean by that. Um, So all the zeros and ones that are given to you, that is one of the starting points, but it's not the only one. The other part of the starting point is what do you understand about, oh, I think the internet connection just went out. Oh, 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 I probably pressed the wrong key. There we go. Okay, so we are back. The recording is still there because, fortunately, I did not use streaming today, so it's all still there. All right, so let me close that. Oh, all right, so let me share screen again in a Zoom session because we have one student who is live with us online because he is still under quarantine. So I'm going to share the screen so that he can see that. There we go. All right. Okay, so getting back to this one. So now the question is, how do we get started with this? Okay, this is given to you. All the zeros and ones are here that is given to you. What would be the next thing that you need to kind of look up in your condensed version of your notes? Yep.
LNO5s.
Say that again.
The LNO5s.
You look up the definition. All right. So I'm going to mute the person who is currently online. Okay, that's muted already. Very good. All right, so we need to get started with all the definitions. So one thing you probably noticed between the first three questions is other than the zeros and ones that are given to you, they are the same nature. So one thing that you might want to do is to basically remember all of those equations that are applicable in this case. So there's the general version, which applies to any base, and then there's the specific version that only applies in binary subtraction in this case. Which one should you be using? But which one? Yeah, is it? Are you going to use the one that is general, regardless of what base we're dealing with, or are you going to use the one that is specific to base two? Specific to base two, because the question is clearly telling you that we are dealing with base two. Okay, now can you use the other one? The answer is yes, you can actually use the other one as well, but it's not going to be as easy to work with. Okay, so now we we try to recall what we know about all this stuff here. So we basically say, Q of I is the exclusive OR between xi, yi, s of I. Oh, no, we don't have s of I in addition. We do have d of I. So d of I is Q of I exclusive OR with t of I. And then t of I plus 1 is not xi and yi, or not qi and ti. All right. How do I know all this stuff? Well, because I quote unquote studied. Okay. In other words, if you're looking at this summary of how we can define how we can relate the bits using the operators, using the Boolean operators alone without using the R and in this case the B function, you probably need to spend more time to review the material and make sure that you are up to date in terms of what you are learning in this class. Because this part is just knowledge. This part has nothing, absolutely nothing to do with problem solving. It only has to do with knowledge. which you can get from the modules, you can get it from the lecture, and hopefully you have been taking notes and you can just review your own notes to get to this point. Okay? If anyone needs time, like 5-10 minutes to get to this point, that would not be a good sign. But that's okay because we are more than 1 week before the actual exam, so that would give some people certain pointers of, okay, maybe I really should be getting familiarized with the definitions and derivations first within the modules. So that's the first thing. All right, so knowing all of this stuff here, where do we start? Well, we look at the bits that are known, and then we ask, how can that be helpful to figure out the rest? For instance, we can look at, I'm just randomly picking a place here. This gets a little bit harder because I have to move the mouse pointer to go to the screen, to kind of show you what I want to show you. And then when I write, I'm going to use the stylus on the other end, but that's okay. So we look at this 0 here, and then we look at this 0 here, and then we ask, well, can we figure out all the bits in between, given all the bits that are already having a value of 0 and 1? That's the question. So you look at this and go like, let's see, what can end up with D0 being 0? There are two possibilities. One is having Qi being a 1 and Ti being a 1. The second one is having both of them being zeros. Okay, so now you don't know which way, right? So what you do is you can branch out and say, okay, let's assume it is this, okay? So in terms of the reasoning, now this is just my line of reasoning. You don't have to explain it in this particular fashion. So this is going really slow because I'm trying to explain each and every single step. So you can say, in order for D0 to be 0, you have two possibilities. You can have Q0 equaling to T0 equaling to 0. You can also have Q0 being the same as T0 being 1. Both of these will end up with D0 being a 0. But in the question like this, we know only one would work. Okay, so you cannot say, oh, it can be either or. That would not be counted as a correct answer at all. So now you have to say, okay, what if Q0 and T0 are both zeros? So in this case, in order for Q0 to be a 0, knowing, okay, because, so you can say because, if I want to use the 3 dots, which one is because? Is it the 2 dots on the top or 2 dots at the bottom? Okay, I can look it up. Because I want you guys to know all the shorthand notation, so this way you don't end up spending a lot of time to write, the actual reasoning. So we are going to look for symbol for because in math. Okay. All right, so the inverted of the therefore, so because is having the 2 dots on top, and therefore is having the 2 dots at the bottom. Okay. All right, so instead of saying BC, you can also use, the 2 dots on top. So let me just use that here. So you can say because x0 is a 0, q0 is a 0 under this assumption, and quote, this rule here, we'll call this rule A, and rule A, that means, that implies that y0 also has to be a 0. Does that make sense? Yep. I'll answer that question in just a little bit. But in order for you to track your line of thinking, your train of thought, not the other way around, you probably want to write it down. It's going to be on a piece of paper. It doesn't have to be like super legible, but it just has to be something that reflects how you think about the problem. So without using this representation, it'll be harder for me to track, the reasoning as well. So now you say, okay, so in this case, y0 is also 0. But if you have x0 being the same as y0, which is the same as q0, which is the same as t0, and they're all zeros, it also implies one more thing. Which bit that is given to you is going to be a problem if everything in column 0 are indeed zeros. The carry bit, right? The borrow bit, t. But this implies t0, okay? So you can say, and another rule that we're going to quote, which is this one here, we'll call this B, this is C, okay? And rule C, that implies T of 1 is going to be a 0. This is a conflict, okay? So that means this entire branch. So it means the left branch, that particular possibility cannot be the case. Q0 cannot be, Q0 and T0 cannot be 0. So the only other choice is both of them are ones. So now you explore this possibility and you say, and this is also based on B, okay? So now you say, okay, what if they are ones, okay? Q0 is a 1, T0 is a 1. So now you say, x0 being a 0 and q0 being a 1. And the rule that we need in this case is A. That implies, what do we know about y? How do we fill in y0 in that case?
Y would be 1,
Y0 has to be a 1, right? Because Q0 is the exclusive OR between X0 and Y0. X0 is already known as a 0 in the given, so that means Y0 has to be a 1. All right, so if Y0 is a 1, would that work out? Is it going to be consistent with T of 1? Yeah, it is now consistent with T of 1, so I'm just going to say that. This also implies T of 1 is 1. And I'm going to have to insert the rule that I use here. This is rule C. And this is, so, at this point, you can write OK, a check mark, this is good, happy face, okay? Just give me a clue that you have concluded that this branch of reasoning ends with a good note, okay? So now we have figured out the question marks, some of the question marks. So I am going to go back here and change y to a 1, q to be q0 to be a 1, t0 to be a 1. So everything is consistent at this point. Is that okay? Does everybody understand how this is all reasoned out? Okay? So the emphasis here is not so much, to focus on this question. I guarantee that this question will not appear as one of your questions. So memorizing this answer is not going to help in any way. What you do need to know is how I worked this out. Okay? I can, basically the first thing, the most important part is, in this case, A, B, and C, the rules, because they came from the notes. This is the stuff that we have learned already. That is the knowledge. Two, you combine the knowledge that we have learned in this class with what is given in the question itself. You relate those things. And three, you apply reasoning, right? So what you do when you apply reasoning is to say, if I know D0 is a 0, that means I know that Q0 and T0, they have to be the same. They can be both ones, they can be both zeros, because of rule B in this case, because of the exclusive OR. So do you guys see how all the different elements are being used to answer the question? Let me, say that. Yeah, go ahead.
Yeah, I understand all the logic, but can you just do the subtraction like as if you just knew the numbers on the first, or yeah, the 0th column? Because I'm kind of confused on how T is 1. That's
Like, which T?
the 0th column T.
Well, T0 is not a given. It is a variable. So it's an input. It can be a 0 or 1, just like all the other bits.
Oh.
Yep. So that's the first thing you might also need to clarify in the class, okay? If you are saying, okay, but in all the exercises that we did, T0 is a 0, you can come up to me and clarify and ask, well, can the T0 be anything other than 0? And I will be able to tell you, yep, it can be anything. Okay? All right? So that's a good question, okay? It's a good question. So in the exam, do not hesitate to ask. The worst thing you can do is to ask me, Tech, I think I got this answer. Do you think my answer is right? The worst thing I can do is to say, I cannot tell you, right? And it wasted like 30 seconds of your time. All right, so now let's work out something that's super duper easy, which is the next question mark. The next question mark that I'm going to work on is this guy over here, which is also known as D1, right? So we can now say because Q1 is 1, T1 is also 1, and the rule that I'm going to cite is which one? Okay, out of the rules A, B, and C, which one is applicable here? Come on, you guys can do this. It's pattern recognition. Which rule out of A, B, and C is applicable to solve the problem of what D1 is supposed to be? B, very good. Okay, so instead of just quoting the entire rule, I just say B, okay? That implies that D1 is a what?
0.
It has to be a 0. Very good.
You could have also looked at just Q and T and did the subtraction there.
Or you can use Q and T as a subtraction, but I would stick with the binary version of stuff, just because that can be helpful in some other way. All right, so we now know this is a 1. Okay, very good. All right, so now we have column 2 to try to figure out. Okay, so this one looks a little bit more mysterious, because we got y0 being a 0, q0 being a 0, and none of the other bits are known. So we don't know what is T3, we don't know what is X2, we don't know what is T2, and we don't know what is D2. D2, yeah, go ahead.
Sorry, sir. I thought D1 is supposed to be 0.
Oh, right, you're right. Okay, I forgot. I think I said the right thing, just wrote the wrong thing. I would be a very ideal kind of spy. I would give misinformation without even trying. The lie detector is like completely flatlined, and I'm telling everything that I say is actually incorrect. That's just a feature of my brain.
Or just the average Twitter user.
I actually do not have a Twitter account. Believe it or not, I do not have a Twitter account.
Hmm? You're not missing out on much.
Well, I don't know. I wouldn't know. But I'll take your words for it. All right. Oh, I just undid my tip on the stylus. Okay, so what do we do with this situation? The same thing, okay? So now the question is, which bit am I going to say, okay, what if this is a 0? What's going to happen? Where do we start? Which bit is going to give us the most information? That is the question. Well, one of those bits is the overflow. Okay, now why is the overflow bit so useful? Because if the overflow is a 1, I would have automatically locked down the value of x2 as well as d2. Let me say that one more time. If I make the assumption that overflow is a 1, I would have automatically locked down the value of x2 as well as d2. Why is that? Well, that's because of rule D, which is now I'm going to write down. Okay, so rule D has to do with overflow. And you all did the assignment of the overflow already. And we talked about the rationale behind the overflow flag. So can someone tell me how overflow is defined in this specific case? You can just say the most significant bit or the sign of blah blah. When does the sign not make sense? Okay, it's okay that you have to look it up. Okay, it's not a problem. That is why you want to have a condensed version of the notes, is so that you can look it up really quickly because you know where you put it because you just put it there within a week of the exam. All right, so let me just quote it for you. Okay, so the overflow is the sign flag of x. In this case, it would be x3 and not y3 and not d3, or not x3 and y3 and d3. In this specific case, I lied because they're not supposed to be threes, they're supposed to be twos. So let me get onto the eraser tool and just carefully erase all the threes because they're supposed to be twos. Because in the more general version, they're supposed to be m minus 1, where m is the width of the operation. So in this case, the width of the operation is 3. So 3 minus 1 is 2. So these are all 2's here. There we go. Okay. All right. So now we try to work that out, and I'm going to have to move some things around to give myself enough space. So give me a second. And just move this stuff over here. So that will give me some more space to do the other part. All right, so now we basically say, okay, what if overflow is a 1? Well, if overflow is a 1, we only have one choice, okay? The reason why we only have one choice is one of the two conjunctions has to be false already. Which one of these two has to be false already? I mean, if you look at column 2, y2 is given to you, q2 is given to you. Q2 is not really helpful because Q2 is not really used. So which one is already given to you?
The second one.
The
Y2
second one
is already, y2 is already 0, right?
Yep. So y2 is already a 0, which means this entire conjunction is going to be 0. What about the other one? Why can't it be this one over here? Well, it's possible. So we're going to say, let's ignore the second one because this one has to be a false. So we will try to see if the first conjunction can be made true, and let's see what the consequences are going to be. So now we go through that reasoning, and then we say, well, if overflow is a 1, using rule D, it implies that x2 has to be a 1 and D2 has to be a 0. Does that make sense? Because in order for overflow to be a 1, the most significant bit of x has to be different from both the most significant bit of y and the most significant bit of d. Right? And so that means the most significant bit of d has to be the same as the most significant bit of y, and also x has to be different from the other two. Okay, but now we have a problem. Because if x2 is a 1, y2 is a 1, it conflicts with one of the known bits already. Which one would that be? Q2. Yep, this implies that Q2 is going to be a 1. This is a conflict. Okay? I'm going to draw a little skull here. Death. Death to this branch. This line of reasoning does not apply. Okay, so if overflow cannot be a 1, what can it be? What must it be?
0.
It has to be a 0. So this process or this kind of reasoning is called elimination. Okay, you try out one thing, it goes like, nope, that's not going to work out, so it has to be a 0. Okay, so that means, okay, taking out of this, it means overflow has to be a 0. Okay, if overflow is a 0, what can we do about that? Well, if overflow is a 0, and okay, I'm just looking at this and find out what other bits we can utilize. Because the L flag can also be useful, but the L flag is not going to be as useful, if you. Okay, so let's take a look at what overflow being a 0 is going to imply. Okay, So if overflow is a 0, that means both sides of both conjunctions, they all have to be false. Does that make sense? So there are many ways for both conjunctions to be false. There are actually 4 possibilities for both conjunctions to be false. So where do we start with that? Well, I'm going to say we'll just go and take a look at the L flag too. Okay, so instead of trying to guess the 4 bits here, the 2 bits over here, I'm just going to say, let's see if we can lock down the L flag as well and see what happens when the L flag is a 1 or 0. So Control Z, Z, like that. So now we branch out again and say, what if L is a 0 and what if L is a 1? So once again, this is also just trying to try out different possibilities and see which one can be ruled out, and whatever is left behind has to be the only one that works out. Okay, so let's take a look at what if overflow is a 0 and L is also a 0. What is that telling us? We need another rule. We need a rule E, because rule E says the L flag is the sign flag exclusive or with the overflow flag. Okay, so what does it mean? If the overflow is a 0, we know the overflow has to be a 0. But we are assuming the L flag is also a 0. So in that specific case, what does the sign flag has to be? Has to be a 0. Very good. So this means the sign flag, which is basically the other name of D2, has to be a 0. Okay. And is that going to work out? Well, let's check out. Because at this point, along this branch of assumption, the next thing we're going to know, so this is based on rule E, and then using, let's see here. Okay, so I'm just going to give you some templates here, and you guys have to tell me which rule can I use and what value will I be able to deduce about T2. First of all, which rule do I use here in order to figure out what T2 is supposed to be? Remember, at this point, we already know a proposed value of D2. We need to figure out what is T2. So which one of the rules, A, B, C, D, or E, do I use in order to figure out the exact value of T2, knowing what we already know at this point? Hmm? Rule B, very good. Okay, so using rule B, what would be the conclusion? So I'm going to put a B here. And what would be the conclusion in this case? What is T2 going to be? 0. T2 has to be a 0. That is correct. Okay, because at this point we know that, okay, I'm going to show here. In the question, we know that Q2 is a 0. Using this assumption, we know D2 is a 0. So using rule B, we are asking 0 equals to 0 exclusive or with something. What is that something? That something has to be a 0. Okay, well, that's a lot of information. Does that make sense to you? Do you think T2 being a 0 is consistent with other bits that are also given to you or you have worked out at this point?
Yeah, for Q1 and T1, we know that there was no leftover carry bits, so
Yep.
their T2 has to be 0.
Yep, so this is consistent. Oops, typo. This is consistent with rule C, where I equals to 1. Does that make sense? Because when I equals to 1, rule B is the rule, rule C is a T of 2 equals to not x1, y1, or not q1, t1. So that in return would basically say, 1 minus 0 does not have a borrow, 1 minus 1 does not have a borrow, so T2 should also be a 0. That is consistent. Okay, so far so good. Okay, So now we have worked out potentially. I'm going to use a different color to indicate this is potential. So we potentially work out this to be a 0, this to be a 0. Cool. What about x2? Can we figure out what is x2? I mean, x2 is one of the first thing we can figure out too.
Yeah. Q can only be a 0.
Mm-hmm.
In that case, if T1 was also
No, T2.
sorry, yeah, sorry, T2. Sorry, I meant
Q2. So we know Q2.
Q2 can only be a 0 if X is also a 0 there.
Mm-hmm. Yep. So in this case, we're using rule A. So all of these together would imply x2 has to be a 0. So that one we know for sure. So that one we can just say, we know this one has to be a 0. So in other words, we have the entire column B to be zeros. But everything works out so far, okay? So the only thing left to do now is what is T3? So T3, okay, so let me go back a little bit. So using rule B, nope, rule C, T3 has to be a 0. Now we worked out everything. Oh, wait, not quite everything. At least I didn't write down everything. So overflow is a 0, and then the L flag is also a 0. So every single bit is now worked out. Are we doing okay so far with the reasoning? Or at least, the line, the technique that I use in order to figure out all the bits. Yes, no, maybe, big questions about certain things. Yep.
I have a question for the exam. For every single number that we determine, do we have to write a statement on why it's true? For every single number?
I would just go with the same representation that I have put up here.
Okay.
And the abbreviation is you can reuse the same A B C D E for all the questions, all the related questions, so you don't have to repeat that portion.
Oh, okay.
Yep. Mm-hmm.
Okay, so can we have an but is it possible that the question has more than one set of solutions?
Nope, not in this case. There's only one possible answer, one possible entirely consistent answer here. So let me repeat the question because I think the person who's on Zoom right now may not be able to hear you. So the question was, for a question like this, is it true that every question only has one specific set of zeros and ones that makes the correct answer? And the answer is yes. There's no ambiguation. None of the question marks could have been a 0 or a 1. Question?
Oh, no.
Nope. Okay. So this is like Sudoku, right? Because you're basically given certain digits. You're given the rule of, what is the rule that you use in a Sudoku? Is it addition? I don't actually play Sudoku, so I don't know.
I can't remember.
But it's something simpler than binary addition. But this is what you do with binary addition. You basically just have to reuse everything that we have learned, combined with what the question is providing you, combined with certain ways of reasoning things out, and come to the answer. Are we good so far? All right. So given the amount of time that I have, I am going to move on to the next question, which is a base 6 question, because question 1 and 2 are of the same nature as this question here, so it's going to be basically the same technique. We can go over those during the lab time because I don't have any actual lab for you guys to do for today, so we can use the lab time to go over those. But for the lecture time, I would like to continue with the other two questions or the other type of question. And that would be question number 6. And I think question number 6 A 4, 5, and 6, they're all in terms of this, they're the same in terms of, oh, wait, I'm not quite done with question number 4 yet. Question number 3 yet. So we have just figured out, okay, sorry. So we have just figured out all the zeros and ones, but that's not the end of the question. There's a reason why I highlighted the first part and then the second part. Why do you think I highlighted that with boldface? Because in the past, some people did not read carefully and they completely ignored the second part. Or I thought they completely ignored the second part. So now the second part is to show how to compute T3 using the following steps. What is the multi-bit P term? For example, if P equals to 1, 1, 0, it means P0 is a 0, P1 is a 1, and P2 is a 1. That's an example. Okay, so the question is, in your case, how do you figure out what is P in this case? Well, first of all, you need to know how the P term relates to the X term and the Y term. How is it related in this specific situation? So there should be several questions popping up in your mind right now. One, where did I see this? When we discussed binary subtraction. Two, where is it in the module that defined the P term? It would be the place right after that really kind of long derivation thing. And I said, okay, let's redefine P and G so that they are different from the P and G from binary addition. They are now defined as follows, blah, blah, right? So what would that blah, blah be? P of I is, go ahead. It would be the negation of X and Y, or Y for P. P is using an or, G is using an and. All right? So that would be the kind of line of reasoning, and this is also why, having all the definitions in one place in a very condensed version of the notes is going to be helpful, because otherwise you're going to have to go through, the modules and try to search for that definition of P term and G term in the context of binary subtraction. That is not going to work well in an exam, because you're already it's already time sensitive to begin with. And the more time you spend to look for something instead of reason out the answer, you're losing precious time. So you want everything to be handy, everything to be accessible on a fairly small sheet of paper, if possible. So in this case, I am going, okay, so I'm reading from the solution that we have. So this is not X or Y as a multi-bit pattern. X is 0, 1, 0 in this case. So it is the bitwise NOT of 0, 1, 0, or Y. In this case, it is 0, 0, 1, and that would be the same as 1, 0, 1, or 0, 0, 1, which is 1, 0, 1 in this case. The G term, on the other hand, is not X and Y. So that would be not X and Y. X is, not X is going to be 1, 0, 1. And Y is 0, 0, 1. When you do a bitwise AND, now we end up with just 0, 0, 1. So these are multi-bit operations. In other words, bit 0 is ORed with bit 0, bit 1 is ORed with bit 1, and bit 2 is ORed with bit 2. You first have to take the negation. Okay, let me use this one. So bit 0 is ORed with 0, bit 1 is ORed with bit 1, bit 2 is ORed with bit 2 to end up with these 3 bits. It is the same thing as using a multi-bit gate. It's just that, in this case, we have a multi-bit operator in an expression. All right, so the third part is asking you to first spell out the borrow look-ahead expression of T3, then substitute each P or G bit with the actual value, then perform the actual computation and get the value. So there are steps involved. The first step is to spell out the borrow look-ahead expression. Okay, so I cannot remember the borrow look-ahead expression. Okay, I know how to derive it, but it's going to take too long to derive it in the class or during the exam. So what do? I would put this into that little condensed version of all the notes, so that way I don't have to search for it. But since I am not I'm not prepared, right? So I'm going to go through the binary subtraction. And binary subtraction is right here. And then we jump to borrow, look ahead. And then we go look up T3, I think. All right, well, there's no such thing as a T3 over here. I'm going to panic. What am I going to do? Okay, so what do? There's no T3 here. I do not know the T3 expression using the borrow look ahead method. So what do I do next? Do you guys remember something about, hey, that looks like the K thing, except all the K is now replaced with a T? Do you guys remember that? And so what am I going to do next? Go to binary addition, right? Okay. So we go to binary addition. There we go. And then we go to, but wait, there's more. And then we look up what is K3. This is what K3 looks like, and replace all the Ks with Ts, and we are done. Okay? So that means, okay, I'm just going to write on the other side. So we have G2. Okay, I'm just going to copy and paste this, so this way you can actually see how I apply that. Okay, copy the clipboard, switch over, and all right. So that would address, one part of the question. I mean, obviously, in a on-paper test, it's not quite as easily done unless you have little stickies, that already have all of this stuff pre-printed, and you just gotta go like, oh, stick it over here. But that's okay. It's not that big of a deal. So now we just have to work out what is G2. So what is G2? Because the question asks, we have to substitute the actual values. So G2 is a 0. What is P2? P2 is a 0 as well. And G1 is a 0. P2, once again, is a 0. P1 is a 1. And G0 is a 0. P2 is a 0. P1 is a 1. And then oh, wait, scratch that. Forgot to take the negation first. All right, so to do this, I am actually, I need to copy and paste this portion. Okay, P is 101. Okay, so let me just write it down. P is 101, and then G is 001. Okay, so now I can switch back to that. Okay, so what I did was I just copied P and G over here, so this way I can show you how to do the actual calculation. All right, so according to this, G2 is a 0, P2 is a 1, G1 is a 0, P2 is a 1, P1 is a 0, G0 is a 1, and then P2 is a 1, P1 is a 0, P0 is a 1, and then K0, we figure that to be a 1, but that ends up as false, or false, or false, or false, which means the entire thing is false. All right, so this 0 here is corresponding to G2. This 1 is corresponding to P2. So is this one, this one, this one. And this 1 here is corresponding to a G0, and so on. Okay, so I'm basically splitting up all the bits put those into binary expressions and evaluate the binary expression. All right. So is that okay? But that completes the entire question number 3. Yes, it took me an hour to explain because I was going slower and try to explain how I reason out the bits using nothing but what we have already talked about in this class and some basic reasoning techniques that is not specific to this class. Yep.
The exam, how much time are we gonna get?
The same time as the lecture,
The lecture.
which is 80 minutes. Yep.
And will there be lab after that or no?
Hmm?
There won't be a lab.
We do not have a lab after that. However, we can use the lab time to talk about the answers to the exam. So if people are interested and go like, okay, I really want to know the answer to those questions, we can use the lab time to talk about the solution, the answers. But remember, it's on a Thursday, so the weekend is right after that. Whether you guys want me to go over the answers, right after, it's up to you guys. All right. So let's move on to the next question, which is a base 6 addition. Now, the base 6 addition, I was trying to be nice, to kind of guide people through the process, step by step. But I have to tell you, last semester, spring 22, a bunch of people did not really know that I was trying to help them, by the first part of the question. So let's read the question together, and then we'll try to figure out, how to solve all of that. This question is about addition in base 6. So it's spelling out right here, addition base 6. X is 121 in base 6, Y is 252 in base 6. First, define R of fg and C of fg specifically for base 6 in the following space. Answering this part correctly is a condition for the next part to be scored, which basically means if people don't know how to define the single-digit sum or the carry for base 6, the rest cannot possibly be done. So I won't even bother to score past this point. And unfortunately, a bunch of people did not answer this part. I'm not sure whether they did not see this as a question or they actually do not know the answer to this question. All right, so what would R of fg be? Okay, first of all, what is R of something? Okay, so you have to give it some context. We did talk about R of something a whole bunch of times for 2 weeks or something like that, when we talked about binary addition and also binary subtraction. In the context of addition, what is R of fg? Fg are basically just names of parameters, so they are basically just a placeholder of, okay, this is one thing and this is the other thing, but what are we doing with those things? Add them together, but there's one extra thing that we have to remember. It is a single-digit sum, which means after you add them together, what else do you need to do? Mod. Right, okay. So this would be f plus g, the whole thing, mod 6 in this case, because we're dealing with base 6. So where did we find all this stuff here? Heck, I do not remember whatsoever that you talked about the single-digit sum for base 6. You're correct, I did not. But I did talk about the single-digit sum for base 10. And I talked about how to generalize that. So where did I talk about that? Which module would it be?
0283.
Binary addition. Very good. Okay. So this is why it is important for you guys to extract all the definitions, all the equations with the context onto a condensed note, so that way it's easier for you guys to look this up. What about the carry? How do we determine whether there's a carry of 1 when we are adding single digit f to single digit g? That's the ternary operator thing, the ternary expression thing, right? So once you can find R, you can find C as well. So this is basically f plus g being greater than or equal to 6 in this case, because if we're dealing with 6, question mark of 1 colon 0. That's it. All right, so this is important. Now, why is that important? Because the next part of the question says, using the general structure of multi-digit addition, Oh, wait, hold on a second here. What do you mean by general structure of multi-digit addition? What is that? What is that referring to? It's referring to how we compute the Q bits, how we compute, in this case, the K bits, and how we compute the S bits. Then you go like, wait, but didn't we just talk about that Q is the exclusive or of X and Y? No, that is a specialization that only works in base 2. All right? So now what do? You basically go like, Q is the R of xy, K is K of I plus 1 is the C of xiyi or the C of qi and then Si is the R of qi and ki. Where do we get all this stuff? Binary addition. Okay, so in binary addition, both in the module as well as what we talked about in class, I defined, the structure of a binary addition, or not binary, sorry, a multi-digit addition, regardless of the base. Okay, so we talked about that. So now we can basically say, okay, what is Q? Well, 1 plus 2, the whole thing mod 3 is still 3. 2 plus 5, which is 7. 7 mod 6 is a 1. 1 plus 2 is a 3. 3 mod 6 is still a 3. K0 is given to you as a 0, so you don't have to do a single thing here. So now the question is, what is 1 plus 2 being greater than or equal to 6? That is false, so it's a 0. Or 3 plus 0 being greater than or equal to 6? No, that's a 0 as well. So this is a 0 at this point. To work this one out, we have to add 2, 5. So 2 plus 5 is 7. 7 is greater than or equal to 6 is true. So the C of x1, y1 is going to be a 1, which means I don't even have to bother to look at the second part because in the disjunction, if 1 is a 1, one part is a 1, the whole thing is going to be a 1. And now we look at this one here and we ask 1 plus 2 is 3, 3 is greater than or equal to 6 is false. 3 plus 1 is a 4, 4 is greater than or equal to 6 is also false. False or false is simply false. Now we go for the single digit sum again. 3 plus 0 is a 3, 3 mod 6 is a 3, 1 plus 0 is a 1, 1 mod 6 is a 1, 3 plus 1 is a 4, 4 mod 6 is still a 4. Done.
It feels so nice going back to addition.
Hmm?
It feels so nice going back to addition.
Yep. Well, just be very careful whether we're dealing with addition or subtraction because the rules are a little bit different. All right, so the next part here is what is the decimal representation of the value represented by the Q row? All right, so the Q row is 313 in this case. So we have 3 times 1, whoops, 3 times 1 plus 1 times 3 plus 3 times 9. And the sum is going to be, so this part here does require you to show the steps, okay? So you have to show me that you know how to do base conversion. All right, so that would be what? I think something is wrong. That has to be wrong here because I was using base 3 and not base 6. Darn it. That would be 6 and that would be 36. There we go. All right, that looks better. So we got 3 plus 6, which is a 9. 9 plus 108 is 117, I think. There we go. I can always double check. And then the S row is 413. So that would be 3 times 1 plus 1 times 6 plus 4 times 36. And that should be, this is why you might want to bring a Dollar Tree calculator. I mean, this is the heaviest duty math that you need to do. Multiplication and addition. Okay, let's see if I can do this mentally. 144 plus 6. So 144 plus a 9 is 153, I think. I mean, you can always change. You can always do the division thing and convert it back to base 6 and see if you get everything back. Now, what if you set up the equation and everything is right, and somehow, using your mental math, because you're basically going like, if Tech can do mental math like that, I can do that too, except you miss certain things. You get a minor deduction, but it won't be a whole lot, okay? Because you show all the steps, you show that you know how to apply the digits, you know how to figure out the value represented by a number. And if you just make a simple mistake of, okay, my mental math just went off by 1 digit or something like that, I'll give you most of the points. Are we good so far? I mean, that's question number 4. So last semester, a lot of people missed, the questions 4, 5, and 6 because they have no recollection of what R and C about. I cannot imagine why. Okay, because we did talk about R, which is single digit sum, and carry quite a bit in the class. So I am not going to speculate why people could not answer this question. Yep, go ahead.
So is the exam basically going to be like this? I mean, obviously different numbers, but like you're not gonna like.
The format can be different too. So I'm just giving you this as what exactly happened in spring 22, but there's no guarantee of what kind of format your exam one is going to look like. So I would, to be safe, okay, to be safe, I would make the assumption that your exam may not look anything like this particular exam, but it doesn't change what you need to know to answer the questions. You need to know everything that we talked about from the beginning of this semester all the way up to and including binary subtraction.
Are you gonna use the extra credit question then?
You must not have read the syllabus. The answer is no.
Also, the spring 20, did you not review over this exam that you did before?
So in spring 22, I reviewed the exam from fall 21, and then in fall 21, I reviewed the exam of spring 21, and so on. And there's one more thing. You can almost be guaranteed that your set of questions is unique to you. I actually have a program to generate variations of questions. So I used to have large classes, like 60 people, and I managed to make unique questions for the entire class. And I'm not just talking about unique combination of questions, I'm talking about unique questions for every single one question for the entire class. Hmm? I have a program to evaluate, the different ways of asking, of changing the positions and whatnot. So, yep. Well, during the pandemic, I basically go like, hmm, well, if I were dishonest, okay, if I was a dishonest person and I say, okay, I'm going to utilize whatever resources that I have without being caught, when I take an exam, what can I possibly do? And within like 2 minutes, I figure out, oh, I could do this. And let me see, can Proctorio catch me? No, absolutely not. Even if they turn on the webcam and screenshots and whatnot, they would still not be aware that I'm using this technique to consult with other people during the exam. So then I just go like, that is going to change the strategy, by which I come up with the questions. So I just have to make it so that honest people would spend the usual amount of time to answer the questions, but people who attempt to be dishonest will be spending even more time in their dishonest endeavor to answer the questions than what it would have taken if they were just to go straight and go answer the questions. I just have to make that cost higher than what it would have otherwise been, because I don't have to catch people. I just have to make it, yeah, not make sense, not economical to do so. Yep, exactly. Yep.
So besides the sample question, is there any way we can practice, like test our, knowledge and things? Yeah.
I'll give you a particular example, which is going to be interesting. Okay, some of you may say, how do I do that? Okay, do you know how to make a random number generator? just randomly generate a number between, let's say, 0 to 7. Okay? So make that, okay? So now you end up with, so I'm gonna capture that, um, in the notes area. So let me switch back to that. All right, so that is a very good question. How do you practice this on your own? So I go to a new page. Okay, so let's say you randomly generate two numbers between 0 and 7. So I'm just randomly picking something from my head, 5 and 4. Okay? So the first thing you do is to say, okay, can I convert these two into binary numbers? Okay? So one is 101, the other one is 100. Now you give yourself the problem of doing one addition and one subtraction. And then you can flip the order unless you end up with two numbers that are the same, which is trivial. So you can now say, okay, we'll work this out. We'll work this out. And then for subtraction, you also want to work that out. So automatically, just from this particular example, I generated 3 questions for myself. Now, this is nothing like the one that you saw in the exam, but I'm setting it up, okay? So now you go like, okay, so we have 1, 0, 0 here, and then assuming a 0 is here, but you can change that too, we have a 0, and then a 0, and a 1 here, and then we end up with 0, 0, 0. Let me double check to see if it makes sense. Nope, does not make sense because I forgot this is supposed to be a 1. And then over here we have 1, 0, 0 again. And because this is subtraction, we have a 0 here and a 0 here, so we have no borrow whatsoever. So that becomes the actual answer. And then over here we have 0 minus 1 is a 1 with a borrow. 1 minus 0 is a 1, 0 minus 0 is a 0, 0 minus 1 is a 1 with a borrow, 1 minus 1 is a 0, 0 minus 1 is a 1 with a borrow. There we go. So with this, I'm practicing going forward, the usual way of using the rules. And then the funny thing is now I can look at this and I say, what bits can I remove and still be able to figure it out using the remaining portion? There's also a physical game like that. You have those sticks things, and you're trying to remove sticks from a stack. And the last one, the person who removed the stick that caused the whole thing to collapse loses the game. What is the name of that game? Yep. So this is like that, except with binary subtraction and binary addition. So now you say, okay, which bit can be gone without affecting the whole thing? Just randomly pick one, right? So let's just say that we take away this bit over here, okay? And then you ask, is that okay? Can I still figure out that bit with all the remaining bits? Easy peasy, right? Because we still know what is the Q and what is the S of that particular column. So using the exclusive OR rule, I cannot remember which one, the A, B, C, D, E, but we can figure this one out, okay? Not a problem. And then you say, okay, what other bit can I just kind of take out without affecting my ability to figure out the rest of the bits? You go like, maybe this one. Yeah, that's an easy one because we still know what is x1, x2, y2, so we can still figure out what is t of 3. So it's more fun when you do this with another person. You pair up with another person and go like, okay, so let's see what other bits we can remove and still be able to resolve every single bit of the entire thing. Is that helping a little bit? Any other questions? That was a very good question about how to have more practice questions, basically on your own. And you can also do the base conversion thing. So instead of using base 6, you can say, oh, I'm going to choose some really oddball, base like base 7. Okay, but the first thing you need to do is to come up with a reasonably large number. Let's say between 1 and you don't want to start with 0. So you want to start with maybe 20 to 1,000. Okay, pick a number between 20 and 1,000, or 500 and 1,000. That's even better. So pick two numbers like that, convert both numbers to base 7, and then you ask, do I know how to do, let's say, subtraction this time using base 7 digits? And apply what you have learned about multi-digit subtraction. So would that help? Yeah. hmm Um, that would be ways for you to practice, kind of like get some hands on, which really helps certain types of people. But if I were to share with you how I prepare for exams when I was a college student, I have to understand the concepts. Once I fully understand the concepts, they can throw any type of question at me, and I'll still be able to kind of solve the problem. So to me, this is just personal experience. It's more important, if I run out of time, it is more important that I can look at every single equation and look at every single symbol and know how it connects to everything else. Okay, that to me is more important than exercises. But every person is different. Remember, this is every person has that person's own journey, own path. Kind of like Buddhism, your path to enlightenment is your path and only your path to walk. There's a saying of if you see the Buddha on the road, what do? Kill the Buddha. I'm not sure whether this is actually just because coming from an anime or actual saying, but the idea behind it is it's not possible to see the Buddha. Okay, so if somebody says, "Oh, I see the Buddha, I'm going to follow the Buddha," that is someone who's blindly trying to follow somebody else's path. And in Buddhism, that is not the way to enlightenment because every person has to walk that person's own path. It's the kind of the same thing when you're studying. Okay, I'm just borrowing Buddhism to explain how to make your own condensed version of the notes, which I think some people say is the study guide. I never really know what is study guide, until I looked it up because somebody asked me. So can you give me a study guide for the exam? I go like, what is a study guide? Yes, I did went through college. I think I went through 9 years of university and never came across the concept or the phrase of study guide. Can you believe that? I can. Any other questions? So there is a reason why I schedule the actual exam to be at least 1 week from the day that we talk about the exam from a past semester, is for you guys to study as soon as possible. And if you have any questions as you study and go like, I'm not really quite sure how this connects to that, you can bring those questions to me in class. You can come visit me during my office hour. Oh, by the way, when is my office hour again? Right before the class, right? Okay, so that makes it kind of convenient. If you come here just a little bit earlier, you can catch me either in the office, or if you don't see me in the office, I'll be in the classroom because I need to set up all the equipment. So that would be a way to contact me to ask for clarification of the concepts that we have learned. You can also come up with problems, like what you suggested, to try to solve, and then you go like, okay, I think I got this, but I'm not sure about my own answer to the question that I generated. Send an email to me, okay, and say, okay, this is the question that I came up for myself. This is my answer. Am I right? Okay, I don't have a problem with trying to figure out those answers and explain if you got the wrong answer. I don't have a problem. Um, Anything else? Any questions from you guys about how to prepare for the exam? Oh, one more thing. This is important too because most people who do not read the syllabus um, probably would not remember this either. It has to do with A, B, C, D, F. Okay, where do I draw the line, right? So the line between F and D is 12.5%. The line between C and D is 37.5%. The line between B and C is 62.5%. And then the line between A and B is 87.5%. So I'm using a linear to GPA scale to grade everything. So when I read an answer, I will look at that answer and say, well, for a particular aspect of that particular part of that particular question, which means your actual score is going to be the aggregate of a lot of subparts. But for each subpart, I will look at that particular thing and ask, is it an A answer? Is it a B answer? Is it a C answer? Is it a D answer? Or is it an F answer? Is that okay? So when I get a weighted sum of all the A, B, C, D, F, for the entire exam, that would be your score for the entire exam. So you're going to end up with a score that is between 0 and 4 for the entire exam, which reflects your actual GPA specific to the exam itself. I need to make this very clear because every year, every exam, I got somebody saying, oh, I think I'm failing this class. I'm getting a 67%. I go like, you're not failing the class. I mean, you're getting a high C. You're just about to get into a B. Oh, okay. I'm not dropping them. Yes, I get that every semester, at least a few times. It does not make the class any easier, okay? Because the question is, when do I switch from a B to a C? What is the difference between a B and a C? And what is the difference between a C and a D? A and F, I think we get it, right? It's the intermediate grades that are a little bit tricky. So you might want to read the syllabus to understand, how I assign the various grades. So basically, I want to explain that a little bit today. So basically, a less than perfect answer, but it is still a good answer, is a B. What does that mean? I mean, it's less than perfect, but it's still good. It means the person is making some, I would say, procedural or minor mistakes and or omissions. So no major concept problems. It's just when that person is carrying out an addition, it's off by 1 digit or off by 1 or something like that. It's a clerical mistake. Okay. So a C is basically someone who barely demonstrates, who gives me enough evidence that the key concept is understood, but the application was flawed. Okay, so there's some problem with the reasoning part, not so much the execution part, but the reasoning part is wrong. But the person seemed to understand, um, how the concept relates to other concepts, just not how to apply that concept correctly in order to solve the problem. A D basically means that person does not demonstrate enough evidence that that person actually understands how the concepts connect to each other. So a D, an F is basically no answer whatsoever, or the answer does not demonstrate any connection between the concepts, or doesn't demonstrate any evidence of that person making any connection between the concepts. Is that okay? So let me just kind of write this down. The difference between an A and a B is going to be in the execution. So there's a flaw in the execution and somehow end up with an answer that is less than perfect, but still good, just less than perfect. Minor mistakes, clerical mistakes, minor omissions, and so on. B and a C has to do with an error in application. The person can make the connection between the concepts, but when it is time to solve the problem, the application of the knowledge is flawed. The difference between a C and a D has to do with, what was it again? Connections. So not enough connections between the concepts. And the difference between a D and an F is basically not even any connection demonstrated at all. Is that okay? All right. So I am done with today's lecture. I can give you a lab that has nothing to do with the exam on next. Oh, what day is our exam? How do we know when the exam is? Okay, let me show you. Okay, first of all, we did talk about it. Oh man, if you talked about it, then what? I mean, how am I supposed to find out? Well, one thing is you can go back and watch all the recorded videos. I mean, that's why I record all my videos. But then someone's going to say, oh, but I don't want to go back to watch all the videos. That's going to take a lot of time. I don't have time to waste. Fine. Look up the calendar. So look up the calendar, and I'm going to show you a few really kind of cool tricks here. Okay, takes a little bit of time. Okay, so when you look up the calendar, and here we have exam one, right? So that's exam one for this class. It is next Thursday at this time, at the time of the lecture, which starts at 9 a.m. It ends at 10:20 a.m. And anyone who is continuing to write past the 10:20 do not have to bother to turn in the answer. I'm not going to collect. That is clearly stated in the exam policy. So stop. Okay? When I say it is 10:20, it is time to stop. Stop writing. Do not continue to write any further. Um, right. Okay. So the cool feature. Has anyone ever explored what is calendar feed? This is one of the coolest things in Canvas. Canvas, for the most part, does not work well for me, but calendar feed is actually pretty cool. So this is calendar feed. So what you do is you learn how to make this feed to feed into your Google Calendar. I assume most people use Google Calendar. This is not an export and an import, okay? The problem with an export and then an import is, well, it will collect everything up to this point that is on the calendar, but if I make any additional items on the calendar, it's going to miss all that. A feed means it is interactive. So every time I schedule something new on the Canvas side, it will show up on your Google Calendar. Okay?
I've been doing it manually. I've been copy pasting things over into my calendar.
Yeah. This will save you from that. And the process to do it, I actually wrote a small, article to do it to teach people how to do it. So you have to go to your Google Calendar site and import an entire calendar. Then it will ask you, what is the URL to import from, and that's when you use the URL over here. Okay. But this is a really nifty feature. The other feature that I think is also useful, you don't have to tell me, whether you have ADHD or not, but I can tell you that I do have ADHD. So, so this feature is called notification reminders. Reminders in Android. It's a really cool feature. Let's see. I'm not sure where. Oh, there we go. So Samsung phones still have this, and I think Android has this in general now. Okay, so let me describe what it is. So I would set up tasks and calendar events and other things. Some are recurring, some are not. But those things are only one shot. In other words, it will go off once, okay, and then it stops. And I'm very, very good at ignoring notifications from my phone if it is a one shot. What this does is it will turn the notification into quote unquote sticky mode, or if you prefer, nagging mode. In other words, until you go to your phone, go to the notification and say, yes, I got it. It will keep beeping you every 3, 5, 10, 15 minutes. You can program that duration. So that's a good way to make sure that you don't miss any task, calendar events, or keep events, and so on and so forth, because it will keep nagging you until you say, yes, I got it. I've done it. I have finished this. Or you can say, don't bother me for the next hour. I'm working on it. Okay? Come back and nag at me an hour later. You can actually do all that on the phone. And I find that to be a super useful feature because this way, I don't actually lose track of what I need to do. But that's coming from a person with ADHD. You may not, your mileage may vary, as they say. Sorry, it's a cultural joke. Not everybody's going to get it. But the idea is, how much you benefit from this concept is up to you. Okay. All right. So I think that is a good place to stop today's lecture. So I'm going to stop the recording, but you guys can stay here and ask questions if you want to, or if you say, For once, I think I want to get out of this class a little bit early. That's fine with me as well. So that's up to you. I'm going to stop the recording and upload it.